Assalamualaikum warahmatullahi wabarakatuh. So for this video, we will try to do tutorial number 2, which is question number 1 from past year March 2017. Let's read the question first. A portion of a high pressure boiler has an internal gas pressure of 5 megapascal. So this is the pressure as shown in figure below. Flange joint involve a cylinder with internal diameter of 250 mm. So this is the diameter of the cylinder. 12 conventional class 8.8. So 12 represent number of bolt, and then class 8.8 is the class number for that bolt. Cause straight steel bolt. So this bolt is cause straight type, which made from steel bolt of a modulus elasticity of 200 gigapascal. So modulus of elasticity for the steel bolt is 200 gigapascal. The cylinder and end plane are made of cast iron of modulus of elasticity 100 gigapascal. So this is the modulus of parts, which is 100 gigapascal. Construction details such as effective area of part clamp can conservatively be assumed equal to 5 times of bolt area. So this is another hint. The joint is reusable, and the question asks first the joint stiffness factor, which is C, and then the diameter of the steel bolt, which is D, and then the minimum grip L if the stiffness constant part. So constant part, which is KP, and then find L. So let us write all the given data here first. So now, first we will try to solve first question, which is joint stiffness factor. So KB we can find from this formula, which is AB EB over L, which is AB times with 200 gigapascal modulus of elasticity for EB and divided by L. Now, given that AP, which is for parts, is 5 times to the AB for bolt, so we can find the KP, which is AP EP over L, and we convert AP to AB, so 5AB times 100 gigapascal divided by L, and then we can get AB 500 gigapascal divided by L. Now we can find the joint constant, which is C is equal to KB divided by KB plus KP. So let's put the value here. So AB 200 gigapascal divided by L, and then divided by AB 200 gigapascal over L plus AB 500 gigapascal divided by L. So simplify, AB cancel out, L cancel out. So at the end we can get joint constant is 200 gigapascal over 700 gigapascal. So our joint constant is 0.286. Now we will try to solve question number 2, which is to find diameter of steel bolt. So refer from table 2.1 under the class 8.8. So you can see that from that table, class 8.8, so the value of fluid strength SP is 600 megapascal. So the value for proof load is SP80, which is 600 megapascal times with the AT. Given that the joint is reusable, so the preload is equal to 0.75 FP, which is 0.75 times with the 600 megapascal times AT. So at the end we can get FR is equal to 450 megapascal times AT. Next, we know that internal pressure, the value of internal pressure is equal to force divided by area. Next, we need to find the value of force, F. So in order to find F, force, we need to know the value of area over area. So in this figure, the area that we need to find is this. Along the section here, where this is the area that we need to find, and then the pressure happen acting on this way, so the value of F is the one that we need to find. So to find area is pi d square over 4, which is pi d 250 millimeter convert to meter over 4. So at the end 0.049 meter square. Then we need to find the internal pressure, which is equal to P load over area. Next, internal pressure is equal to 5 megapascal, equal to P load over area, which is 0.049. So at the end we can get P load is equal to 245 kilonewton. Because in the question there is no mention about factor safety, so assume that factor safety is equal to 1, and N is equal to SP80 minus Fi over Cp over Nb. So factor safety is equal to 1, which is 600 mega times 80 minus 450 mega times 80 over C, which is 0.286 times 245 divided by 12. So 150 mega times 80 is equal to 5.839 power of 3. So at the end we will get value of 80 is equal to 3.893 power of negative 5 meter square. So refer table 2.2. The value for 80 is 3.893 times negative 5 meter square, which is 38.93 millimeter square. So from table 2.1, under the column cost rate, our value for 80 is 38.93, which is somewhere in the middle. So we cannot take the value of 80 is equal to 36.6 because 36.6 is very smaller than 38.93. So we need to take a higher more, which is 58.0. So from value 58.0, we can see that the value of nominal diameter is 10 millimeter. So we select 10 millimeter for nominal, which is major diameter for steel bolt. Next, for the third question, we will try to solve to find L, which is the minimum grip. So first, let us find the value of AB, which is pi d square over 4. So pi times 10 power negative 2 square over 4. So we get the value of AB is 7.85 power of negative 5 meter square. Next, we'll find the value of KB, which is AB EB over L, where AB is 7.854 power of negative 5 times with the EB, which is 200 gigapascal, divided by L. So we simplify, so at the end we get 15.708 mega divided by L. Given that stiffness constant, which is Kp, is equal to 1931.7 mega Newton per meter. So the value of C we can find, which is Kb over Kb plus Kp. So 0.286 is equal to 15.708 times power of 6 over L divided by 15.708 power of 6 divided by L plus 1931.7 power of. So simplify, we can get the minimum grade, which is L, is equal to 20.302 millimeter.